Metal-air battery. Metal-air battery are a class of extremely interesting batteries characterized with a huge specific capacity and a huge specific energy. Basically, in the next lesson we will see one of the most classic example of metal-air battery, the zinc-air battery. So in general, when we are speaking about metal-air battery, we are speaking about batteries that are built in a way in which one electrode, the anode during the discharging, is basically just a simple metal. It could be zinc or another types of metal. What is important is that this metal should have low molecular weight and low reduction potential. So basically we need to use a metal that is a strong reducing agent, something that can be oxidized in a easily way. Why? Just in this case, since the electrical potentials of the anode is smaller, we are able to generate a higher output voltage. And so together with the low reduction potential associated with the metal used as a cathode for these batteries, as the negative pole more precising, we need to use something that is characterized with a quite low molecular weight in order to increase basically the power and the energetic density, and at the same time also something that is abundant and maybe cheap. Basically, if it's true that in a metal-air battery one electrode is composed of the metal, so this is the metal, it could be zinc for instance, or aluminum and other types of metal. This electrode that is the negative pole acting as anode during the discharging process, it should be characterized with what we have already said. So a quite low reduction potential associated with this metal and a low molecular weight, and it should be cheap and abundant. For instance, the zinc is a metal that is able to meet all these requirements. So this is important because if the electrode just simply is lighter, this means that we are able to have a battery that can provide a certain energy, but is lighter, and so the energetic density and the power density is huge if this material is lighter. So basically we want to reduce the weight of the battery, maintaining the total energy stored. And in which way we can do that? Selecting a material that is lighter and so with a low molecular weight. So this is in order to improve, for instance, power and energy density. Then we have the quite low reduction potential. Why? Because we know that the total DDP of a battery is basically the difference between the potential of one electrode and the other one. In this case, since during the discharging the electrons are proceeding in this direction, and so this is the negative pole and this is the positive, we are imagining that this electrode potential, it will be higher with respect to this one. And so if the total DDP, the final output voltage, is basically the difference between this electrode potential and this electrode potential, if this is smaller, so it's very low, the difference it will be higher, maintaining the same value of this one. So if this is a fixed value, if we are able to decrease this potential, the difference it will be higher, and so the total output voltage it will be higher. If we want to ensure a good DDP, we need to use a metal that is characterized with a redox couple, so a similar reactions associated with the reductions of that metal that is characterized with a reduction potential that is very low. So this is in order to increase the DDP. So we want to have what is known as strong reducing agent. It's a strong reducing agent because it's able to reduce strongly the other species, and so we have an interesting tendency to be oxidized. So if it's true that here we have a negative pole that is a metal acting as an anode during discharging, but this is a metal, what we need to say is that if this is a metal, the second type of electrode it should be air. Air. But what does it mean, air? That if the reaction proceeding during a discharging process on the negative pole is, from a generic point of view, this one, the oxidation of a metal. So we have a metal in the metallic state 0 here, the generations of these cations due to this product of the oxidations, and the electrons start to move in this way. So here we have the oxidation reaction. We have the anode in this case. Whereas when electrons are entering here, we need to have something that is reduced. And so we need to have a strong oxidant species. So something that tries to oxidize the other one, because it's reduced. And this huge oxidant, it could be, for instance, oxygen. So in the positive pole here, and this electrode, let me picture it in green, we have that the reaction that are proceeding is obviously a reduction in according with the working principles of battery. And this reduction is the reductions of oxygen. So oxygen plus 2 water plus 4 electrons together. This. So here we are passing from oxygen 0 to oxygen minus 2. So basically we are proceeding with a reduction of oxygen. Here we have the oxidations of the metal that simply is lost in the electrons, and these electrons are collected from the storage circuit and taken from oxygen in order to obtain these reduced species. So this is oxygen, or better air, but in general the only species interesting in the air is oxygen, because we know that air is not composed as only oxygen. Air is composed as oxygen, is composed as CO2, carbon dioxide, and is composed of nitrogen. So why I'm saying this? Why I'm saying that this is a metal air battery and not a metal oxygen? Because obviously, from a theoretical point of view, what we can do is imagine to compress oxygen under pressure and use this oxygen maybe as a pure oxygen in the battery. But this it does not make sense. Why? Because oxygen is present everywhere in the air. And so a more smart solution is avoid to use pure compressed oxygen, but as smart solution it could be taken oxygen directly from air. And so this particular type of electrode is an electrode that is known as GDE, gas diffusion electrode. A gas diffusion electrode is a specific type of electrode composed of different sections. We will see the different types of section composing a gas diffusion layer in dedicated lessons speaking about zinc air battery in the next lessons. But in general, for now, what is important to say is that these particular types of electrode is made of a porous materials and a specific catalyst that is able to allow oxygen to enter inside this zone and be reduced from air. And so we are basically collecting the reagent for the development of this reaction from the atmosphere. And this is a huge interesting advantage. Why? Because if the reagent is present directly from the external environment, we are simply saving weight. We are increasing a lot the energy efficiency, and not the efficiency, sorry, the energetic density. Why? Because basically if the reagent is taken from something that is outside, our system is lighter. because we are not filling it with more weight, with oxygen directly inside this device, but the oxygen is taken from outside, and so the battery is lighter, the weight is reduced, because this species is taken from outside. And these are huge advantages, and these are the reasons for which metal-air batteries are one of the most interesting batteries in terms of specific energy. We have a huge amount of stored energy for unit of weight. Why? Because these devices are really lighter, because oxygen, that is one of the two reagents taken in order to proceed these reactions, is taken from outside. And this is an advantage. But the fact that we are using a gas diffusion electrode, this sort of porous electrode that can collect reagents from the outside, is an advantage, obviously, in terms of energetic density, energetics in specific energy, but we have even some problem. And these problems are, for instance, the fact that we are in a situation in which oxygen is not present, or purely present, maybe in marine environmental, we are not able to use these types of battery. For instance, watches for submarine application. Obviously, inside the sea, underwater, the oxygen level is extremely low and not obviously allowed to enter inside the gas diffusion electrode. And so what does it mean is that basically in each single situation in which oxygen is purely present, these batteries cannot work. Another important problem concerns the fact that in air, how previously said, we have oxygen, but we have even CO2, and we have even other species, so maybe nitrogen. Well, nitrogen is completely inert, and so is not a problem in this case, but CO2 is a problem. Why CO2 is a problem, we will see this later, but basically CO2 the carbon dioxide, can enter inside this gas diffusion electrode together with oxygen and can be dissolved in the electrolyte, causing some problems. But in which way basically we are saying this? So we have between the two electrodes we have one electrolyte, and this electrolyte, as always in battery, is able to cross the circuit. In metal-air battery, electrolytes are often aqueous electrolyte. For instance, in zinc air, we are speaking about an alkaline electrolyte composed as potassium, so potassium hydroxide. Basically, what is happening is that in the moment in which CO2 is entering in the gas diffusion layer, so we have the diffusions of oxygen in order to ensure the working of the battery. This oxygen, together with the water in the electrolyte and the electrons arriving here, can react in order to achieve this reaction and so ensure the workings of the battery. But together with the oxygen, we have also the carbon dioxide. And the carbon dioxide can enter inside the electrolyte, passing from the gas diffusion layer. But the electrolyte is an aqueous system, often. So maybe it's an alkaline, often aqueous system, but it's an aqueous system. And so we can have is the dissolutions of this in water with the carbonylation, the formations of carbonate and hydrocarbonate that can modify the conducibility of this system. And even when the concentration is huge, can even promote the formations of precipitate. And the conducibility is reduced anyway because the mobility of these anions, the carbonates and the hydrocarbonates, is more with respect to the mobility of H- OH- present at the very beginnings of the battery. And we can even have the clogging of the GDE pore. And so basically a lot of problems concern the presence of CO2. And we have even other types of problems. So even if it's true that the metal-air batteries are extremely interesting for the huge specific energy, due to the fact that we are saving weight with these smart types of electrode, we have some problems concerning, for instance, the anode and concerning the cathode. The problem concerning the cathode are the fact that this cathode allows also the passage of CO2. And since it's porous, is able also to promote the evaporations of water from the electrolyte. And so we have a concentration in the species inside the electrolyte that can cause precipitation and even changing the conducibility. But we can even the opposite. In an environment in which we have huge moisture, we can have the vehiculations of water from outside inside. And so in this way, basically, again, we have the dissolution of the electrolyte, and again, in a different way, the conducibility is modified. We have the formations of hydrocarbonate or carbonate in the carbonylation. So basically, the gas diffuse electrode can cause a really amount of problems in our electrolyte and so in our device. But often it's composed also with a Teflon membrane, so something that can induce a certain hydrophobicity. We will see later all the components of a GE, and this is due to the fact that in this way we are more able, induces a certain degree of hydrophobicity, to tune and manage the water and tries to avoid an excessive penetrations of water in a moisture environment, or maybe also avoid an excessive evaporation of water. So we have some problem concerning both the electrode and also the cathode. Another problem concerning the cathode represents the huge overtension when we are exploiting high current. Why? Because we know that when we are close to high current, we have a huge problem concerning the mass transport. And in this case, since the reagents are not already present, but needed to be diffused from the bulk, and in this case it's just the atmosphere inside the electrode reaching the catalyst, so the site in which actually the reactions occur, well, the diffusions can be hindered when we are looking at high current, so we can have a really important limitation due to the diffusion. And then we have even some problem concerning the anode. But the problem concerning the anode are more important, and we will see this point during the recharging process. And even if from theoretical point of view, some metal-air battery as zinc or as zinc-air batteries are rechargeable, are secondary battery, we have some problem due to the anode. For instance, due to passivation, due to bad redepositions mechanisms with the formations of the sedimentations, and also due to the corrosions of the electron with the side parasite reaction. We will see all these types of problem concerning the rechargings of the electrode, speaking about the zinc-air battery in the next lecture. But now, basically, what is important to know about the metal-air battery from a general point of view is known.